All right, good morning, everyone. Today we're going to be going over relational database management systems, RDBMS, and I forgot the B in there. All right, there you go. So today we're going to talk about why we would want to use a relational database. And we're going to talk a little bit about data persistency and why it's important to have a database to retain information, or what the benefits are over utilizing something as simple as a CSV. Now, all of us have a little bit of experience now working with CSV files. We've had them on prior assignments before, and more importantly, in our assessment. In our assessment, we have to work with a series of CSV files to try to get a functioning program for a video store. Now, it wasn't part of our assessment for the video store to be able to retain data. But can anyone think of a way that we could have done that in our program, where when we added a client that was retained data, and the next time we run our program, that client still existed within there?
You would do write instead of adding it like an object. You
Yeah,
could write the CSV.
yeah, that's perfect. You could do a little bit of CSV writing, right? But the point is that our Python program only retains memory, or is only able to hold to information, as long as the program is running. So that raises a couple of issues, right? If it's only retaining information as long as the program is running, that means that as soon as I kill the program, that information is now gone, unless I'm writing in an external source. Now, whether that's a JSON file or a CSV file, that's up to us. But more commonly, data will be stored inside of CSV files. All right. Let me see if I currently have this data. Okay, so currently we can see this data of a CSV file for students, right? It's opened up in an Excel sheet. Obviously, if this was to continue and we had a lot more students, this data would extend, right? And we would have a series of students with their grade, their age, their last name, and first name. Well, with Excel sheets, or with sheets on Google Sheets, when you go to download this stuff, you could always choose to download it in a CSV format. And that's the reason why we see CSV files more typically as the source for retaining data, right? Because at some point, everyone is trying to retain their information for their small business within a Google Sheet. And then either a Google Sheet or some sort of Microsoft Excel. And then once they're ready to actually have an app or have something that can actually retain their information for them, well, the easiest way to do this is by downloading a CSV file, right? So you download a CSV file, they give it to you and they tell you, hey, here's my CSV file. Here's all the data that I currently have. I want you to create something for me that retains all of this information. I'm able to add to it. I'm able to manipulate the data as I wish. Okay. So now, so far, the tools that we have available are going to be Python, right? We have Python, we have CSV writer, and we have CSV reader. So here's the same file. Let me see if I can make this look pretty. There you go. So here's the same exact file, right? It has an ID, it has a first name, the last name, and it has the same exact information. So it's as if the client just gave me this CSV file. So now with the tools that we've learned so far, obviously my automatic response would be, oh, okay, perfect. Well, I can create a Python program that would take care of this, right? But then that, again, that consists to have a couple of issues. Now, this CSV file, if this CSV file were to get lost, what would happen to all the data within that CSV file?
It disappeared.
Yeah, it would be completely gone, right? There's no way to have some sort of data persistency to ensure that the data is actually being saved, maybe in multiple sources, to ensure that if one of them goes down, we have another copy of it. There's no way to allow the client to have immediate access to it unless they have some sort of knowledge about how to utilize things, or certain technologies, right? So with that said, maybe Python isn't the best source to be able to read and utilize this data. Now, the other thing that I wanted to talk about when it comes to the CSV files is going to be data persistency, right? Or consistency, I apologize. right here, we can see that all the first names and all the last names are coming in with capital letters at the beginning, right? And maybe there's a certain limitation that we need to set for age. Maybe there's a certain limitation that we can set for grade. And sure, we can hard code all of those things, right? We can make an extensive Python program that will take really a lot of detailed information of like, hey, only this input is allowed. If this input is entered, it needs to be in a specific way so that it is valid data. It's data that matches the format that we need it to come in, so that the data can continue to be persistent throughout the entire sheet. But that's a considerable amount of work to do with something like Python, right? So let's try to tackle this utilizing Python first. We'll create some sort of terminal program that will allow us to view the students. And then after we can see what it looks like when we utilize Python, then we can move on and try to refactor it and say, well, this is why we would want to use something like a relational database rather than utilizing something like Python and a CSV writer to be able to read or write our information. So there's some pretty common things that we've already known. Maybe I can open this up side by side. Oh, that's not what I meant to do. There you go. Okay. So now we've already talked about the fact that all of this information is getting saved into a CSV. So with that said, what would be the first thing that I know I'm going to have to import into this program?
CSV.
Perfect. I'm going to import a CSV. We've already talked about classes and how classes should look. And it seems like the student information comes in a pretty formatted way to where I can create a class for a student. Does anybody want to walk me through interpreting this data into a class?
Class, then student. Yes, and then DEF underscore net, and then it would be self, comma, ID, then first underscore name, then last underscore name, then age and grade.
Okay, so now we have all of our arguments that we'll be receiving from the CSV file. How do we give these arguments a value of a property under the instance of the class?
Do self.id equals ID. Self first name equals first name. Self last name equals last name. And same with the age and grade.
Okay, great. So now we were able to create a class for a student, right? That student is able to receive an ID, is able to receive their first name, their last name, and their age, and their grade, which is all the fields that we have here in our CSV file. Okay, perfect. So now we have to actually be able to read from the CSV file. We could create a class method to be able to do this, or we could just have a function that would be able to do this. Whichever one we would prefer. I think at this point, I want to create a function since it's necessarily, I wouldn't want a student to be able to read data of a student, right? So I could have it be either a class method or I could have it be a function. Which one of the two would we like to do?
Do a class method.
Okay, so let's start with the class method. How do I build this?
You start with your function decorator at class method.
Okay, so I have my class method. Great.
And then you define a method. Yeah, it could just be read students. And then with colon or class, I'm sorry, CLS in the parentheses. And then with open parentheses path.
Okay. What would be the path?
You'd have to
I think I got it.
you could import an os.path.
I think I got it. It's this.
Okay.
This path, yeah. Okay.
And then for row in reader.
Okay, let me add the new line here. As file. Okay, and then, oh, you said you wanted this to be reader, right? Okay, so for
yeah.
row in reader.
You could just do print row.
Okay, so there's a couple of things here, right? We're able to open up the CSV file, and we know that once this function is done, since we're using with open, it's going to automatically close. We have this new line, and we're telling our Python program to identify this file as reader. Now, once this is over, right, we're telling it for row and reader, meaning that reader would have to be iterable. So let's try to run the program and see what information we get. Okay, when I print the program this way, I'm simply just getting each individual line as a set of string. That's not necessarily what we want. So there's something that I'm missing within this function. Can anybody walk me through it?
We need to make a list.
All right.
We also need that star, I think.
Okay, so at
That's
some
just
point,
like,
you're saying that at some point I'm gonna have to do something like star row.
yeah.
Okay, I see on the chat someone is saying something about dict reader. Okay, so how could I apply dict reader here?
So you do the reader equal to no, not the reader. I think you have to do, yeah, you can do that reader dot equal csv dot did reader fantasy reader passing.
Okay, nice. So these two are the same. That could be confusing. Maybe we should name this one file and this one. Okay, so then reader is going to turn into CSV dict reader. It's going to take in that file and it's going to create a row for every single one of those dictionaries. Okay, let's see what it looks like now when I run the program. Okay, great. Now I'm actually getting these dictionaries for each one of those student data entries. And then Clarice, you brought up the star row, and we also have this students list. So what is it that how do these two relate? And what's the next step here? What's the next thing that we need to do now?
Would we do students dot append and then do class parentheses star row?
Yeah, let's do that. So students dot append and then CLS star row. Okay, great. So that should get us a list of students, right? And then at the end of this function, we would probably want to return those students. So let's print out that list and return students. So now when we run this, we can see the list is being printed. And here we have a list of student instances. Okay. Great. So we're able to create this read students function. All right. Well, now how can we add a student?
We could have a function that takes in each of the like first name, last name, and then create a class instance out of it.
Okay, great. So I'm assuming this is also going to be a class method, right?
Sure. Yeah.
Okay, so let's create a class method. Def create a student. All right. So how do we create this student? And we have a couple people who are consistently quiet, so I'm just going to start calling people. Let's see. Let's start with Anthony. How do I create this student?
Do you want to do it like based off of the terminal or
Yeah, it's going to be a terminal program. So
you could let like first name equals user input, like what is your name,
okay,
or
and
input, my bad. And then what is your name? And then you would repeat that step for like every other attribute that exists in the class.
all right. What's the next thing? Age. And I think the very last one that we need grade.
And then you'll also need like a new ID, and then you'll add one to the key so that way the next one will generate as ID 6.
Well, that's not something we currently have. Do you want to add something like that?
What do you mean?
Yeah, because right now we don't have something that we could add the ID to,
Oh,
right? So
so you
how,
have to make like an open dictionary.
one more time?
Tripping. Like you would want like a student's dictionary.
Okay, yeah, so then let's create the student's dictionary. So student dict be equal to first name. Okay, so we have our dictionary. We have first name, last name, age, and grade. What about the ID portion? How do we fix that?
Wouldn't you need like a empty dictionary at the top, like a global dictionary, so that way when you access it, you can add one to the key? So like maybe under line 4, make a new student's dictionary, or
I
is
see.
that not necessary?
I see what you're saying, but currently right now we're just working off of a student's list.
Hmm.
Do you want to create a class variable? We could do it.
Well, maybe you don't have to. You could just maybe append that new student there and then take the new length of whatever that list would be.
Okay, yeah, let's do that. Let's do. Okay, so we have all of our students, we created all this, and you're saying to take the length of it, right? Which should be,
Yeah, once you append that new student, then you would take the, or yeah, you would just take the length as it is now and then add one.
okay. So then that's gonna take in our IDs, it's gonna create a student, et cetera, et cetera. All right. So this is for creating a student. We have a dictionary, but we still haven't created a student. How do I save the student into that list?
Do you append it? Or
What am I?
Update.
well,
Oh,
no, but
wait, you are
you can't
appending it.
append a student dictionary.
No, it is to the list, right? We made a list to put all the students in, so a pin should work.
Oh
Yeah.
yeah, then maybe append student underscore dict.
I think we have to make a student object first, don't we?
Yeah, perfect. Thank you, Kate. So let's go ahead and do that one. Let's do CLS. And let's utilize that star method again and pass in the student dictionary.
Hmm.
Okay, so now we went over how to create a student. Now the next part is how do we delete a student? How do we want to handle that?
You pass in the student ID and then you search for it and then delete it from the array or dictionary.
Okay, so df delete a student CLS. So then you're saying to grab in the student ID.
Pass a ID to. Oh yeah, okay. Yep, you can input one.
Okay, so I get that student ID. What's the next step?
You want to see if the student ID exists in the dictionary. So, or and then if it exists, you delete it from the dictionary.
Okay, so for ID or for stud in CLS.students. If stud.id is equal to stud ID, then you're saying to remove it. So how do I remove this one student? What method am I?
I think the remove, not remove, or the delete. We can use the delete keyword.
Well, I don't think delete belongs to a list property, but remove does.
Remove.
Okay, so then stop. Okay, and so that's
And then true if you deleted it, or true false, return false if you didn't, I guess. Or you could print, if it were to a terminal program, you can print, student deleted, and then outside the for loop. And then return right there, yep. And then outside, print student was not found. And then maybe we just return. Well, you don't have to return.
Okay, perfect. So now we created a small terminal program that's able to read from our CSV file. We're able to add a student and we're able to delete a student, right? But now my question is, even after we add the student or we delete a student, how are we saving this data? How is this data being saved onto the CSV file?
We need a write function, like a write to the CSV.
Okay, so let's do a class method and let's name it save data. So then again, you said that we need a writing function. So this is probably going to be something that I do with open again. Okay, so I'm going to say with open. I'm gonna specify the file path, which in this case is going to be data.csv. I'm going to say that the new line, I have to specify the mode in this case because it's going to be writing. And I'm going to make a new line as such. Okay. So now I'm not reading, I'm writing. So I'm going to say writer is CSV dot writer. And that writer is going to take in the file. And now I'm just going to say writer dot row. I think I'm doing this wrong. Yep, I am. Writer dot write row. There you go. And then I'm going to specify the fields that it needs to take. So in this case, it's going to be ID, first name, last name, age, and grade. Okay, and now for stud in CLS dot students. Oh, go ahead, Cody.
Just if you specify a field that doesn't exist in the CSV, will it throw an error or what would it do?
It would overwrite that field and create a new one for it. So all of this entire current CSV would essentially be rewritten from top down. So if I make any mistake here and I pass in something that doesn't exist, or I miss one of these fields, that field would be gone forever.
Oof.
So are there ways to, like, what happens if I don't know, you run into like a runtime error while you're writing? Is it like normally best practice, like store it as like its own separate thing first, and then once it's like fully written, like swap it, or is that just never happens really?
Well, typically you would never want to utilize the Python program to read and write data on its own. You would want to utilize a Python program to communicate with some sort of database to grab data and then read and write a CSV file or load data, either or. Right now, what I'm trying to show everyone is kind of like the purpose, right? I'm trying to make sure that everyone can identify the struggles and the problems behind not utilizing a relational database management system. And then afterwards, we can go into the relational database. Does that answer your question, Matt?
Yep, gotcha.
Yeah, sorry if I spoiled the fun and jumped the gun.
No, no problem at all. Yeah, did I make a mistake with one of these?
No, you didn't. I was just like, I'm watching you write code. I'm like, dude, I would mess all of this up.
Okay, and then, so now we would actually pass in the fields, right? Which is the ID, the first name, the age, and the grade. Okay, we have all of our methods. We've created our program. So now let's actually create a little recursive function that we can just call, right? So let's say while true, so that it continues running. And let's just say, okay, how do we want to manage this? Let's say, one is view all students, which we haven't created a method for. So we'll have to create one for that as well. Two is add a student. And three is delete a student. And then finally, let's do four is exit. Okay. So now let me go ahead and make these real quick. So if choice is equal to 1, then we'll have to pass for now. If choice is equal to 2, then we want to add a student. So we already talked about this. We want student dot create a student. Okay. Otherwise, if the choice is delete a student, which is 3, then we want student dot delete student. Okay, and then if the choice, I guess we could just do else for time purposes, then we would want to break, right? So let's go ahead and load all of our student data. Okay, so now this method for viewing all of the students, how can we do that?
Should we make a string, that underscore string thing?
Yeah, we definitely can. Let's go ahead and do that. What would you like it to take in? Or what would you like it to return?
And just, yeah, the student's ID and first name and last name, well, all the information
Okay,
in
so
like an F string.
okay, so self ID. Ooh, that's gonna be a lot of info. Let's do it.
Couldn't you just also unpack the dictionary with the dict dunder?
You know, I was actually thinking about it and it went across my mind and then a part of me was like, that might be a little too much if I throw it right now in the mix of everything. And now I regret it because you asked about it, which means everyone's likely comfortable with that. All right. Okay. And then for this, then I guess we could just iterate through it, right? So for student in student dot students print student. Okay, let's run our Python program and see what happens now. All right, so if I click on 1, I can view all students. I can see the ID of 1, their first name, their age, and their grade. Okay, perfect. If I want to add a student, so what's my first name? Let's go with Francisco. Last name, age, and grade. Okay, now if I go to view all students, oh, Jesus. What just happened here? Oh, I see. It's this. Okay, view all students. Okay, that stayed the same now. Perfect. All right. And then Francisco, Avila, 20. Okay, and now if I go to view all students. All right, so I already identified one problem. Can anybody tell me what the problem here is?
It lets you take in your grade as a lowercase when it should be like capitalized.
Yeah, it lets me take in my grade as a lowercase when it should be capitalized. And then also, if you notice all of the names here, the names are capitalized, but my input wasn't. Right? And then I see the number 6 here for ID. So now I wonder what happens if I do this. So let's say I want to delete a student, right? And I say that I want to delete the student on number 2. It tells me the student deleted. Okay, if I look, I see 1, 3, 4, 5, and 6. So it worked, right? But when I go to add a student, once again, let's say Adam on age 18, grade A. Okay, well, what happens if I view all students now? What other problems have we just noticed?
We can have duplicate IDs.
Yeah, we can have duplicate IDs. We just don't have a really good data control over everything that's being inputted into our system, right? And then I'm pretty sure that we also messed up in the fact that we created our ID as an integer, because now when I go to delete a student, even if I put the number 6, this is a string. And when we went to create our student dictionary, we created IDs for new students as integers. Right, so I could easily fix that and turn this back into a string, but we can see how now we created an issue with data types, right? Not only are we not ensuring that the data is being entered in the correct way, but we're also not making sure that the data is being entered with the correct type. Now, what does that mean? All right, well, let's say I want to add a student again, and I just make it something like this. Well, what if I put dragon for age, and for grade, I put 57? Well, now when I go look at my data, we can see what we have here, right? We have all this information. Now, obviously, I would want to write all of this stuff, and I would want to save it. So I could say something like student save data. Right, so let's exit. Let's run it again so that we can actually see this in action. So let's add a student. Let's say Francisco, Avila, age, PR, grade 57. Okay, now let's remove a student. Now let's add a student. Adam. 56 or 52, age 20, grade alpha. Okay, well now when we go to exit, we can see that our our CSV file was rewritten, right? But now when we rewrite our student's CSV file, one, we lost the data entry of number 2, which that's okay, that's what we intended to do. But now we have multiple keys of 6. These 2 entries does not match the same format as the ones before. And we can see how our data in our CSV file is being corrupted. Right? Although we were able to create a terminal program that could do this, and we did it not necessarily pretty easily, but we did do it in a comfortable amount of time. Having to add all of these extra parameters and extra left and rights of what's acceptable and what's not acceptable, handling user error, it would be a considerable amount of work, right? Also, what if I wanted to only see the students who were above the age of 18? Or what if I only wanted to see the students whose name started with a letter E? Well, I would have to go into my program and create an entire method that would be able to do that one thing, right? So this entire exercise this morning was just to show us, like, okay, this isn't the best way of solving this problem of data retention. Why would I want to use a database for this, right? So now with that said, we came up with all of the reasons why this isn't the best way of handling data. And instead, we would want to use a relational database system. Now, a relational database system works kind of like this, right? And feel free to, I think it's draw SQL. There you go. Oh no. Yeah, so now in the relational database system, what we can do is we can create a table. This table can be named student because it's going to be our student table. It would have an ID. It would have a first name. We can specify what kind of first name it will have. So in our case, it would be something like a character count, right? Because we can ensure that it's only characters. We can have a last name, which again, we can ensure it's only characters. We can have an age, which we can make sure that it's an integer. And then we can have our grade, which is only just characters once again, right? And this essentially looks exactly like the class, right? The biggest difference is that now when I go to create this information, or this information gets saved in my database, this is going to have some sort of persistency for all those things. It's going to know, oh, okay, well, I see this input, but it's supposed to be an integer. And if I try to put anything inside of the database that doesn't match these requirements that I have here at the very basic level, my database is going to tell me, hey, we can't accept this data. It's dirty. You have to go and clean it and then attempt to load everything to the database again. All right. So in this morning, basically what we've covered so far is why we wouldn't want to use Python or use CSVs as a form of retaining data. Does anyone have any questions about these two parts that we covered this morning?
Hey, Francisco, I have a quick question regarding like when would CSVs come into play? Is this like if someone passes you some data, like a set of data that you want to add to the database?
Your question was, when would CSVs come into play?
Yeah, so like we're just never going to use CSVs ever again, switch databases, or is there still a purpose for them?
Yeah, that's a great question. So the majority of data that's being passed between, either between a developer to another developer, or maybe it's being passed between clients, or later on when you guys are working in your group projects, you guys want a way to interchange the data between one another so that everyone's working with the same information, then you would want to utilize something like a CSV file, right? You can't give someone the same database that you're working with. So you need a way to empty the database that you're working with into some sort of file that you can give to another developer so that that developer can load that same exact information onto their own database. Does that make sense, Robert?
Yep, makes perfect sense. Thank you.
Okay, perfect. Okay, so we've been going on for quite a bit. Currently, right now, it's 9:40. Let's go ahead and take a 10-minute break and come back at 9:50 and actually start our databases. Thank you so much, everyone. Okay, welcome back, everyone. Before we took our break, we went over a lot of the basics that we've covered so far. How to work with CSV files, how to create a class, and how to create a terminal program that would be able to read and write onto our CSV file. Now, while we were on break, I went and reset the CSV file to what it used to be so that we have clean data once again. And now that we've talked about why it's not a good idea to utilize something like a CSV to retain our data, we're going to start talking about database systems. So today we're going to be using Postgres, and pretty much the entire duration of this program will be using Postgres as our relational database management system. Now, Postgres is a very popular framework, and it's being used by many different companies, and it utilizes SQL as its main language to be able to grab and store information or return data to the individual developer. Now, something fantastic about Postgres is that we're going to see how we can connect our Postgres database to backend servers. And essentially what it's going to do is it's going to allow our Python code to be able to run SQL queries in a specific manner so that we can grab specific information out from our database and return that to the client. So now let's go into actually working with Postgres. So currently on my terminal, I already have Postgres installed. I can do something like, I think it's brew services. Oh, no. Okay, there you go. So there's my brew services. It's able to run. It's telling me that I have an old version of Postgres. Its status is none, and the user is the root user. But the one that I currently have running is version 15 of Postgres. It started, and it's telling me that I'm the user who's using it and where its exact location is. Okay, great. So brew installed Postgres for me, and I know that Postgres is running correctly. I believe for anyone who is a WSL user, I believe the correct command for you is Pseudo services. I have to look it up what it is for WSL. But now that I know that my Postgres is running, I can do something like PSQL Postgres. And when I run PSQL Postgres, I'll notice that my terminal now looks different, right? It's telling me, hey, you're in a homebrew server, and it looks like PSQL is at version 14, but I'm working with version 15, and it tells me that I'm working now in Postgres. Okay, great. Now, what exactly does that mean? Well, that means that all of the commands that happen in here will have to be SQL commands now, right? If I try to run something like clear, nothing's going to happen. If I try some running any other type of terminal command that isn't SQL related, it's going to throw me in a syntax error. So let's go over a couple of common SQL commands, right? So let's say I wanted to see all of the other databases that are already created within Postgres. So I can do \L, and that's going to bring up a list of all of the databases that I have. You can see that I follow some sort of a common practice where for every database, I always do _DB. It seems like a couple of them don't have that, but that's just something I do to make sure that I know that that's a database, right? It's just follow it by _DB. And then you'll also notice that all of my database names are in lowercase letters. I do not use uppercase letters. And the reasoning behind that is because Postgres has a huge problem with capitalized letters when it comes to actual databases being created. So please do not use any capital letters whenever you're creating a database. So I'm able to do something like this, and I can see all the list of the databases that I have. Now I can look at relationships that are also within the current database that I'm in. So right now I'm in Postgres. If I run /d, it's going to tell me, hey, you don't have any relationships. There's no table that has been created in here. So let's start actually creating a table. Let's create a database. Let's create a table, and let's go over what that looks like. So in order to create this table that will be able to handle these students, we have to create a database. So let's say create database. Notice how everything's in capital letters. And then I can say the name of the database. So in this case, it will be students. Now, any SQL query that I write will always end in a semicolon. If it does not end with a semicolon, the only commands that will not end with a semicolon is anything that starts with a \. So now I put my semicolon there. I ran create database, and it tells me, hey, I created a database. So now I can ensure that it did create that database by running /L. And I can see that students has been created. Does anyone have any questions over what I've covered so far? It's important that everyone is able to maneuver through their Postgres very well.
Yes. So when you made this database, where is it saved at? Like out in the internet or like saved to your machine?
No, it's actually on my machine. So when I ran brew services, where is that command? Oh no, it's too far back. I can't see it anymore. But when I ran brew services, it tells me that my machine is running Postgres in the background, right? It's running it as a background service, meaning that there is a port being utilized to run Postgres the entire time. Just like yesterday when we utilized live server, it utilized a port to be able to host our HTML template on the browser. Well, Postgres is utilizing a port within our machine so that it's continuously running and accepting data. Does that answer your question, Cody?
Yes.
Awesome. Yes, that port is 5432. Thank you, Will. Okay, perfect. So let's continue moving forward here. We can see that we created the students database, but I'm not connected to it, right? Well, that's where we utilize the \C, and that stands for connect. So I'm going to say I want to connect to the students database. And now when I run this, it gives me a message saying, okay, well, SQL version 14, et cetera, tells me you are now connected to database students as the user, Francisco Avila, which is the root user. All right, that's what we can see here. And now we can see that instead of Postgres on the left side, I have students on the left side, meaning that I am within the correct database. Okay, but again, if I run /d, it's going to tell me that I don't have any relationships. That means I don't have any tables in here. So let me go ahead and create a table real quick. So for creating a table, I'm going to say create table student. And then I'm going to open up a parentheses. So the good thing about SQL is that it's very much plain English up to a certain point, right? I want to create a table. Well, the command for creating a table is quite literally create a table. So then after in my parentheses, that's where I'm actually going to pass in the arguments for creating this table, right? So I do create table. Well, what is it that I want to create in this table? Well, I want an ID, and this ID is going to be a serial primary key. That means that it's going to be a primary key that is serialized. Okay. What other fields do I need? Well, we know I need a first name. And that first name, like I said before in our drawing, will be a character. And I can give it a limit, right? I don't think there's any first name that's going to be above 20 letters. So let's say that that limit is 20. I don't want it to have any more than 20 letters. Then I can go into last name. Same thing. All right. I can do my age, which when we talked about the age in the drawing, we also said, and I have that right here. Oh, I apologize. I have a question. Go ahead, Robert.
Two things real quick. When you did create table student open parentheses, you then hit enter, and then you proceeded to enter your, I guess, title headers here, titles.
That I pressed enter?
Yeah, you hit enter after that parentheses.
Yeah, so I hit enter after this parentheses, and that's a really good point. Let me cover that now to ensure that everyone's understanding it. When we saw before, whenever I finish running a command, it would always return to Postgres equals and then ampersand, right? Well, in this case, I have students equals ampersand, and then I go to create a table, and I leave that last line with an open parentheses, right? Well, now notice that in the next couple of lines, it doesn't show me students equals ampersand. It shows me students with an open parentheses ampersand. So although this is a new line, it knows that I'm not running the command, right? The command isn't done yet. It's accepting arguments for that command. Once I close it and I add a semicolon, that's when it would actually execute the command that I entered as an SQL query. Does that answer your question, Robert?
Yes, it does. Thank you. And just a quick heads up, you misspelled the first name.
Oh, that is a good heads up. Thank you. Oh, well, no. No. Okay, so now I'm gonna have to restart all over again. So create table, student, and then ID, serial, primary key, first name. Thank you. Good looking at varchar 20. Oh. Last name, varchar 20. And I think that's where we left off. Okay, perfect. So now I can add age, which is going to be an integer. And then finally, I can add my grade, which is going to be a character, all right, because we only want one character. And this character would just be 1. Okay, so notice that after every argument, I'm putting in a comma. But in that last argument, I will not place a comma. I will just close the parentheses and add a semicolon. And this will execute my command. Okay, so now we see a table was created. Okay, so I ran create table with an open parentheses. I pass in the arguments that I had, right, which is the same thing that we drew here. I have an ID, I have a first name, last name, age, and a grade. So I specify the ID, which is a serial primary key, meaning it's going to be serialized. So every time there's a new data entry, instead of me worrying about increasing the value of that specific number, so instead of worrying about me having to do the logic of 1, 2, 3, 4, 5, and then any new entry should be 6, 7, and 8, it's going to take care of that for me. It's going to say, okay, well, this new data entry came in, we're going to go up one. And if I delete an old one, it's not going to care what was deleted. It's going to continue to only increment in my data, in my ID for the primary key. I have a first name with a character count of 20, a last name with a character count of 20 as well, an age that only takes in an integer, and a grade that only takes in one character. And it's able to create my table. So now if I run \d, oh, hello. To see my relationships, we can see that I have two tables that were created. I have the student table that was created, right? And that's the one that I manually just created now. And then I have this student ID sequence that was created. And that's because we have a serial primary key. So Postgres is taking care of the serializing of our primary keys and ensuring that they're incrementing in the background for us. And this right here is the one that I created myself personally. Does anyone have any questions about that?
I just have a quick question. What is the difference between the varchar and just char?
Yeah, that's a very good question. So the difference between varchar and char. So how do I explain this? The main difference behind them is the amount of space that the data actually takes in once you're actually saving it. There's a couple of limitations to one and the other. And it might be a little too early to explain it now in detail. Once we go into the week of Postgres and we're actually breaking down databases, then we'll go into each one of these fields and what exactly they're doing. All right, awesome. So now I have this information, right? And that's great, but I currently don't have any data in there. Well, I have this CSV file, and I know that later on in my career as a software engineer, I'm more than likely going to have to work with CSV files to place data into my database. Well, how can I enter this into my database, right? That's the next question. How do I do this? Well, what we're going to utilize is the copy command. And before we do that, let me run pwd here. Okay, so I have two terminals. One of them is describing the path to where my data.csv will be located. So I'm going to go ahead and copy this path here. And my second terminal, I'm inside of SQL. So now I'm going to specify, hey, I want you to copy. I'm going to specify the table that I'm going to use. So I want you to make student entries. And I want you to make these entries from the following file. So I'm going to paste the path that I just copied. And I'm going to do data.csv. So it knows what file it's going into. Now, when it comes to strings or specifying paths in SQL, you'll always have to utilize the single quotation mark. Do not try to use double quotes because that will throw a syntax error. Okay. And then afterwards, I'll just have to tell it, hey, there's a delimiter, which is a comma. And there are CSV headers for you to utilize to be able to read this information. Okay, so what is this saying? It's saying, hey, I want you to copy from the student table, which we created. I want you to make student entries into the student table. And I want you to grab the data for the entries from the following file. So it's going to go inside of my computer into users, into myself, go into my desktop. Then it's going to go into the Victor curriculum. It's going to go into 4-full stack. Then it's going to go into 2-intro to SQL. And after it enters that last directory, it's going to grab data.csv. So it's grabbing this file. Then I'm telling it, hey, all the data is separated by a comma. So it knows that each portion of my data is separated by a comma in between it. And then I'm telling it that it has CSV headers, meaning that each one of these headers or the first line will be read as a CSV header so that it can relate the number 1 to ID, John to first name, and enter the information the way it's supposed to be entered into my database. Right? So now let's run this. Looks like I got a syntax error because I can't spell delimiter, I'm pretty sure. Data.csv. Yep, I can't spell delimiter. Okay. And now it told me, hey, I copied 5. So it was able to copy 5 entries. Now look at this. 1, 2, 3, 4, 5. So all 5 entries are now within my database. Well, now how do I see that? Well, in Python, when I wanted to see all of my students, I had to create a for loop, right? That would be able to iterate through all the students already inside of my list. And then I had to also create a dunder method that would be able to show me all of that information. Well, in SQL, it's actually much simpler. I can run an SQL query. And in this case, what that SQL query would be select. So I'm telling you, I want you to grab this specific information. So I want you to grab everything from the student table. Now, when I run this, we can see, okay, well, I'm going to grab all of the entries, right? That's the star. It's saying everything from the student table. So here we see ID, we see first name, last name. Oh, did I not record? Okay, no, I'm still recording. Okay, we see last name, we see the age, and we see the grade. And all of the data entries have been placed inside of my database, and it's matching my SQL queries. Does anyone have any questions about what I've done so far? Are these commands the same on Linux, WSL, as Mac? Once you're inside of PSQL, all of the commands that I've been demonstrating are the same. The command to enter SQL might be a little bit different, though. Does that answer your question, Matt?
Yeah.
Do you always need absolute paths? That's a really good question. In my experience, I've always provided absolute paths, but I'm not sure if there's might be like a shortcut to be able to make it happen. I'm sure that if you know enough about Linux, you could probably use a couple of different pathing tools to ensure that it's able to find the correct file. Any other questions?
Could you go over kind of just like everything that you've done, like as far as like how you made everything?
Yeah, definitely. Let's cover, let's see how far back I can go here. Okay, so it's able to let me go all the way to the beginning. So let's take a look here. Right, so first I was able to enter Postgres by running PSQL Postgres. Once I entered Postgres, I wanted to see all of the databases that I had. So I ran the command \L. And with the command \L, it was able to show me, hey, these are the current databases that exist within Postgres. Okay, fantastic. Then I wanted to see if Postgres had any data tables. So I ran a \D. It did not have any data tables. So my next thing was to create a database named students, where I could store all of my student-related data. So I created a database named students by running the command create database, followed by the name of the database, all in lowercase letters and closed with a semicolon. So then Postgres told me, okay, I created a database, you're good to go. And I wanted to confirm that. So I ran a \L. And by running a \L, I was then able to see that students had been added to the list of databases within Postgres. Well, then the problem came, how do I connect to students? Because I was currently connected to Postgres. So in order to connect to students, I ran a \C students. That then connected me to students. And I knew that it connected me to students because it changed from Postgres equals ampersand to students equals ampersand. All right. So once I had that information, I wanted to see if there were any data tables inside of that database that I created. So I ran a \D to see if there are any relationships. And it told me, hey, you don't have any relationships so far. So you have to create a table. So I went into creating a table. This was me causing an error because I misspelled first name. So I had to reattempt that command. So I ran create table. I named it the student table. And then in parentheses, I passed the arguments for what that student table would hold. It would hold an ID, which would be a primary serialized key. It would hold a first name, which would be a series of characters up to 20. A last name, which would be a series of characters up to 20. An age, which would be an integer. And a grade, which would just be one character. And I gave it the limit of 1. And then it didn't run this command until I closed it with a closing parentheses, and I placed a semicolon. The moment that semicolon appears, that's how SQL knows that I'm ready to run that command.
So could you like group commands together? Like once you're more comfortable, like could you have created the like database and then the table right after and started doing that all in like one line, or do you have to first create like the database and enter it and then start creating stuff in there?
Yeah, that's a really good question. So later on, what I'm going to go over is going to be something called an SQL file. And an SQL file is something that you can just type in all the commands that you would want to do, right? From top to bottom. And then you just run that file and all those commands would happen sequentially. But we're not quite there yet, but that's a great question, man.
Hey, Francisco. Where you restarted the table, what did you press, like that caret C?
Yeah, that's Control C. And that's just to interrupt whatever function is happening on your keyboard.
Oh, okay. So that will kind of delete everything that you wrote previously and allow you to restart?
Right. So you can see here how once I started with the opening parentheses, it gave me an opening parentheses up to this point. And once I ran Control C, it's essentially saying, hey, I want you to cancel what I was working on. And it returned to equals ampersand.
Okay. Okay. Thank you.
Of course.
How do you go back to Postgres?
With the same command that we utilize to connect to students, you could use \C and then students, and then Postgres instead of students. And that would put you back in Postgres.
Thanks.
Of course. All right. So then finally, after I created the table, I ran \D to confirm that that table was created. And it told me, okay, yeah, I created the table that you told me. And I also created an ID sequence so that every time there's a data entry into the student table, we know what the next ID should be. Finally, the last thing that I did is I copied student entries from the file, the CSV file that we had. I told it that each one of those entries or each one of those cells, data cells, were separated by a comma as a delimiter. And then I also told it that it had CSV headers so that it can match each one of those headers to a specific field, right? So then I said, okay, well, this first line is headers. So I know this line isn't supposed to go into the database. It's just telling me that every single first entry from lines 2 through 6 is coordinating to the ID. The second entry from lines 2 through 6 is coordinating to first name, and so on. Once that command was successful, it told me it copied 5 entries. So it copied 5 rows of information. And then after that, I ran a query to ensure that that happened. I told it, I want you to grab all the information from the table of students. And that's how I got these nice 5 rows printed into my terminal. Was that a good review? I think that was Matt Lewis that asked me.
So when you hit copy, is that the part that's updating your new database, or what was the select part doing? Like, what's the difference between the copy and the select?
Yeah, that's a great question. So copy is actually grabbing the information from my CSV file and placing it inside of the data table, whereas select is just grabbing that information out from the data table and displaying it to me on the terminal.
Okay, like a print.
Exactly, kind of like a print statement.
So could you just do a select ID from student and then would it just do the ID numbers or?
Yeah, that's a fantastic question. So let's say select ID from students. And I would just return this series of IDs. Okay, so we've gone over quite a bit. Before we continue, let me make sure that this is good. Actually, we're gonna have to finish off the lesson before we can go into any practical application. I apologize, everyone. I wish there was a natural breaking point, but it doesn't seem like there is in this case. All right. So now we've gone over how to copy from a CSV file. We've gone over how to work with this information and how to enter the information from a CSV file into our database. Well, before we start going into how we can run all different types of queries, let's start talking about how we could work things rather than doing it through a terminal, doing it through an SQL file. Well, in an SQL file, what you'll want to do is something like you can write the same exact queries that we just wrote, but we can write them inside of an SQL file. So, for example, we can do something like create, and we can see that it's recognizing it, table, and I just want to create the table for the CSV data. So I'll just have you guys walk me through that since we already practiced it once. So how do I create the table of students for the students inside of the CSV data?
Student, open parentheses.
Perfect. So then student, open parentheses.
ID, serial, primary key.
Nice. I'm surprised you remembered that one.
I wrote it down.
Oh. Okay.
That's why he's the GOAT.
Yeah. So now we have our ID with a serial primary key. Okay. And then I could also show you guys this, right? So we have this ID, this student that we made, and we know these are varchars and which ones are integers and characters. So what would be the next portion here?
First name, varchar, 20.
10? Okay.
Oh.
Sorry, I'm having trouble hearing you. Did you say 10 or did you say a different number?
I said 20.
Oh, perfect. All right. So now we got our first name, we got our ID. What's the next one?
Last name, varchar, 20.
Yeah, so last name, varchar 20.
Age, integer. Grade, char 1.
Okay, so now that we have our data table that will be able to take in this information. All right. Well,
Hey,
oh, go ahead.
hey, sorry, quick question for Cisco. When you're writing it here in the SQL file, do you not need the semicolon to end this command?
Do I need a semicolon?
Yeah, so when in the terminal, when we're doing it, the semicolon ended it. Do you use that here as well?
Yeah, so once this actually gets interpreted in the terminal or once we run it against our database, this is essentially the same thing as if we were running it in the terminal, right? So we need to make sure that we follow the same regulations. So yes, you will need that semicolon.
Okay, copy. Yeah, I didn't, I guess I didn't see it right there. Sounds good.
No, after you said it, that's when I added it. I missed it.
Oh, okay.
Yeah. Okay, perfect. So now we have this information. Now we've already gone over how to copy information through our CSV file, right? I can just copy and paste this command if we really wanted to. Right, where we're telling it, hey, this is what I want you to do. I want you to, oh, I want you to copy from students. Let me try to fix this here. Okay, so I want you to copy from this information. Here's my delimiter, and then there's some CSV headers. Okay, yeah, I could do something like that, right? But that's not necessarily what I want, or what I would like to demonstrate this time. This time, what I would like to demonstrate is how to insert data, right? So now, if we wanted to insert data, it's actually, it's going to be pretty simple for us, right? We're just going to say, hey, I want to insert into students. So I want to insert into the table of, into the table of students. And here are the values that I'm going to insert. Now, we know that Postgres is taking care of the ID for us, right? So if Postgres is taking care of the ID for us, should I try to manually add an ID in there? No, right? I should only do that if it's 100% necessary, right? So instead, all I'm going to focus on is going to be the first name, the last name, age, and grade. And I'm going to specify here are the values, right? So these are the things that I want to enter into the student table, but here are the values that I want you to use. So the values that I want you to use are going to be they're going to be John. And I'm just going to actually put in the same exact thing that we have before here. So I want John, I want Doe, I want the age of 18, and then the grade of A. Same thing, separated by a comma. So the next one's going to be Jane, Smith. Notice that I'm still only utilizing single quotes, not double quotes. 19, and their grade is going to be B. Okay, then the next one will be Bob Johnson. Would be 20. Their age would be, their grade would be Charlie. Finally, we're at Emily. Oh, that's not what we wanted. Williams. Age 18. Oh, that's then Alpha. Okay, and then the last entry, which will be Michael Brown, and they are age 19 with a letter grade of B. Okay, so I'm telling it, hey, here are the values that I want you to enter. And each one of those values is separated by a comma, right? Except for the last one. The last one does not have a comma. Instead, it has a semicolon. And that's going to input all of these data entries into my my data. And actually, let's make an extra one just so that we know that it's different. So now let's say Cisco. Okay, so now we have all of this information. How do we confirm that this data was entered into my table, right? How can I see all of this data?
Select star from students.
So select star from students with a semicolon. Okay, perfect. So now that I have that information, let me go ahead and connect over to Postgres. Oh, that's not it. And the reason why I'm connecting over to Postgres is because I'm going to erase the database of students, right? Because I'm going to be creating it all over again. Oh, excuse me. I'm going to be dropping the data table of students. So let me go over to students. Ooh, and I think we can do drop table if exists. I'm pretty sure that's a valid command here. Let me make sure.
Do you need the semicolon?
I am getting the semicolon, yes. But I'm trying to remember if that's the correct syntax for it or not.
It's on that cheat sheet that Dakota put in there. It says create database if not exists, and then I assume if exists works as well.
Okay, so we'll run it this way then. Okay, so now I have my students. I'm inside of the proper database. I can say, hey, well, I want to see the relationships. All right, so we see that the relationships I currently have is student and student ID sequence, right? I can also say that if I run select all from student, I have all the way up to Michael, which is great. Well, now what if I wanted to run this specific file? Well, in order to run this file, I would just have to tell Postgres where this file is located. So I could do something like \i and then specify the file, which in this case, it would be students.sql. Oh no. No such file or directory. No, it's probably going to take an absolute path over to it. I may have to debug this one. But let's see what I can do here. Okay, let's see if that works. Okay, yeah, so that did work. All right, I just had to pass in an absolute path. So the first thing that we see that was executed is the drop table if exists. So we see that it was able to drop the table. Afterwards, it created the table student. So we can see that the student table was created. And then I inserted data. I proceeded to insert 6 data entries. So we see insert 0, 06. So it inserted 6 entries. And then afterwards, I run my select command, which is select all from students. And it was able to select all of the information, ID, first name, last name, and age from all the students that I passed into it. Now this is updated because it has my name on it. Sorry, seems like I think somebody had a question. What was the question?
I'm not the person that had a question, but I do have a question.
Okay, yeah, perfect.
Can we run the commands like the \c? So like if we wanted to create a database and then do \c to connect to it and then create the table, can we do that in the file?
In here? Oh.
Yeah.
Try this out. Let's see. Let's say we want to create database. And let's see, this database is student trial. Okay, and then afterwards, I want to connect to this database, which is student trial. Well, let's see what happens when I run this command. Okay, yeah, so it seems like everything worked, right? So here's the path that I told it to go to. It was able to drop the table, create the table, insert 6 rows. It runs my select query. It created a database, and then it connected me to student trial. Did that answer your question, Megan?
Yes, thank you.
Of course. So the SQL file is essentially just a script file for SQL commands. Exactly. Yes, that's all the SQL file is. It's just commands to be executed by SQL. Students. There you go. Okay, perfect. We've been going on for quite a bit. Before we start going into SQL queries, let's go ahead and take a 10-minute break, and then we'll go into SQL queries and talk about the different queries that we can utilize. Thank you so much, everyone. I'll see everyone here at 10:45. All right, welcome back, everyone. So far we've gone over how to create the how to work with CSV files, how to create our database, how to create some sort of data retention. But now let's talk about the different type of SQL queries that we can run, right? Which is the important part. So the main benefit of how to utilize this information, right? Before we went into before we started talking about SQL and actually going to databases, we created this program. And this program took quite a bit of building before we got it to do what we needed to do. But then we realized that it was also very limited. And if we wanted to do something else for grabbing data, we would have to create an entire method for it. So now let's say that I just wanted to grab student first names and last names. How can I do that? Can anyone think of a way that I could do that here?
I think like select, and then you would put first name here, I believe, instead of asterisk.
Yeah.
Then comma, last name from student.
Perfect. So I could just run something like this, which is a very basic, which is a pretty good command here. And now when I run it, we can see that instead of showing me the entire table, it's just showing me their first name and last name, right? I can also give them headers, or I can give them nicknames. I can say, hey, I want you to run, give me first name and last name. But I want you to do it as F name and last name as last name. I believe that's how that works. Yeah, so I can give them titles as well, right? I told it, hey, I want you to give me first name, but instead of writing all the first name in here, I want you to just give it to me as first name or F name and last name. But instead of writing the entire last name portion, I just want you to give me L name. So I could change the headers as well. All right. Now that's useful. But what if I wanted to grab something more specific? What if I just wanted to grab the students who had a grade of a B, right? How can I do that in that case? Right,
You
so
could do.
Go ahead.
I'm gonna say do select, and then do you want just still the first and last name, or do you want the whole row?
Let's do the whole row for now.
All right, select star from student, and then where grade equals without the spaces around it, I believe, and then the grade that you want it.
Okay, perfect. Yeah, so I'm gonna pass an SQL query and saying I want you to grab all of the information from the student table where this entry has the grade that's equal to B. All right, so now when I run it, we can see that it's grabbing those students. All right. Well, this is great, But what if I wanted to do something more specific, right? What if I just wanted to see the count of these students? Well, SQL also has some math operators. So I can run count of all, and this should just return 3, right? It's telling me, hey, the count of all these entries is 3. So now I know that 3 students out of the entries in my database have the grade of B, right? I can also pass in something like grade and then run this. And now let's see the difference between these two. From student where grade is equal to B. Interesting. What is it saying? Column student.grade must appear in the group by clause or be used in an aggregate function. I see. So I have to group it, right? So it's causing an error. Now, notice that when I did the count, or actually we could just scoot up and see it, right? So the first time I ran this, it showed me 3 separate rows, all for the letter B. But when I ran the count function, instead of showing me 3 separate rows, it just showed me a total number of rows that it would return, which is 3. So now if I try to add something like grade to the front of it, it doesn't know what to do because it knows that it's only supposed to return 1 row for the number of rows that pertains in there, which is count 3. But when I tell it to also return grade, well, now it wants to give me those 3 rows of B, and it's kind of conflicting. So now I want to isolate this behavior. And that's where the group by clause comes in. So I'm going to say group by grade. And what that is saying, hey, if they are the same, rather than giving me 3 separate rows, just give me the 1 row of and group them all by the ones that are the same. So it's saying, hey, I want you to group them all by grade, right? Well, now if I run this, it's going to give me the grade is 3. I mean, the count is 3, and it's going to tell me that all of the grades are B. And it would be the same as if I run A. If I run this, it would tell me, hey, there's only 2 of them, and they all have A's. And that's how the group by function works. Does anyone have any questions over these queries so far?
So is the select when you give it that like that grade, that's just setting the column name? So could you name that whatever you want, and then as long as you're still like that doesn't actually, I guess, have to match with anything in the database. It can be whatever you want it to be. It's just typically you do like that because it's easy to make sense of like what we're actually querying or grabbing.
No, so this actually does have to match the database, right?
Okay.
So if I put something random, like I don't know, let me put letter in there. It's gonna actually bring up a syntax error, and it's gonna say, hey, I have no idea what this field is. What I can do is specify grade and give it an as argument, and then run it, and then it would be able to work, right? But what it's actually retrieving is the field of grade for each one of these data entries. It's just giving me a different header because I'm giving it an alias, right? Kind of how Python 3, we have an alias and now it's just Python. This is all the as argument is doing, but it does need to actually match one of these fields within the table.
Yeah, the count with the star like confused me because I guess there's like stuff going on inside of there that or SQL has knowledge of like what to do with that, so it knows to put the count as a column name.
Yeah,
that's what I got confused because to me I was like, oh, you can. It looks like it just took count and it was like, oh, make this the name, make grade the name, and then do whatever.
Yeah, no, that's a good question. So when it comes to this count function, right? It's a function, and what it's doing under the hood is it's essentially saying, okay, it's running the entire query, seeing how many columns are coming back, right? And then once it sees how many columns come back, instead of returning all of those columns, it just counts how many columns there would be. And that's why we only see 2 in here. Rather than 2 columns, we see there being 2. Does that make sense, Matt?
Yeah, that makes sense. Thank you.
Okay, perfect. Are there any other questions?
Yeah, Francisco, I've got a question. So I know when we're entering all this data, we are only supposed to use single quotes. Are there instances where we actually need to use double quotes, or is it going to be always just single quotes?
To my knowledge, you shouldn't be utilizing double quotes at any point. Anything inside of SQL will always be single quotes. Perfect. Okay. There's only a couple of other commands that we're going to go over together as a class, and then afterwards we'll break off into some groups, and then we'll tackle the first 2 assignments of the day. That way as a group, that way we can ensure that we're getting that cumulative exercise for retention. All right. So now, what if I wanted to order students, right? Let's say that I want to grab all the student names. So let's say I want to grab student's first name and last name, and I want to do it from students or from student. I apologize. And when I run this, I would get it all back. But what if I wanted to be ordered in alphabetical order by last name? Well, Postgres knows that I may need to do that. So it has a function named order by, and then I can tell it that I wanted to order by last name. And now when I run this, we can see that it turned all the data entries so that it's ordered by the last name in alphabetical order. And it will do the same thing as if these were numbers, right? Now, what if I wanted this to be upside down? What if I wanted W's to come in first? Well, Postgres also knows that that's something that we may need to do. So it has an argument called descending. So now when I run it, instead of showing it from top to bottom, it's showing it from bottom to top. It's just like a reversing of the query. Now, what if I just wanted to see the last 3, right? I don't want to see this entire thing. I only want to see the last 3 people. Well, I can just add a limit. I can say limit 3. And now when I run this, I can see that it only returns to me 3 rows, and they're in reversed alphabetical order by last name. Does anyone have any questions over order by, descending, or limit?
Can you filter it just by like the first letter of their last name?
Yeah, you could definitely do it by the first letter of their last name. So let's say I want select first name and last name from student, and then you said the first letter of their last name, right? Where last name like, and which letter would you like there to be?
I don't know, S.
Okay, S. I believe that's the correct one. Yep. So now I'm going to tell it, hey, I want you to grab the first name and last name from the entry in the student tables where the last name looks like this. And I'm telling it, it looks like it starts with a capital letter S, and then everything after that doesn't matter. I just need to know that it starts with a capital letter S. And that's how it returns Jane Smith. Go ahead, Robert.
Yeah, I just wanted to clarify, whenever you're typing these commands such as order by, desc limit, group by, when you're typing the actual command, like on line 25, does it matter what order those are in, or can you mix and match those in any order basically?
Yeah, that's a great question. They definitely do matter as far as what order they're in, right? So I always want to run my select clause first. Afterwards, I want to run my from clause. And then third is my where clause, right? So the ones that are necessary is going to be select and from. The ones that are optional are going to be where. And then after that, any other type of argument that I want to pass into it. So let me see if I can bring that back, what I had before. There you go. Limit 3. So limit should always be the last argument, right? Because it's a limitation. It's like, hey, after you run this entire query and you grab all of my information back, then I want you to limit it, cut it to how many rows I want. And then descending should be either last or second to last. In this case, it will be second to last because I want to see the limit 3 in after I've reversed it. That's when I actually want to see the limit of 3. Right. And then order by, it's kind of a sequential order thing, right? I don't want to flip it upside down if it hasn't been ordered yet. So I would always want to order it first and then flip it upside down. Does that make sense, Robert?
Yes, makes sense.
Awesome. Okay. Now let's say that I wanted to see all the students, all of their information. And what I want is the students where their age is between 18 and 19. Well, now when I run this, it's going to show me all the students with the ages between 18 and 19. I could also run something like this, where age in, and then I believe I can do this, 18 or 19. And that's going to return me the same thing, right? But if I had something a little bit more spaced out, maybe between, well, those are all the available ages that I have right now. So this is something else that we can do. We can run the in clause, where we're checking if it's inside of some sort of series of data. Or I can always say it like this. I can say where the grade is equal to the letter A. And then I can pass a secondary command where it says, and the age is greater than 18. Or the grade is equal to B. Oh, and we want a capital B. And just like that, we just linked a bunch of conditionals together, right? So I want you to grab all the students where their grade is A and they're older than 18. So this is all one command, right? So let's see. Here's 8. Here's 19, 20. Okay, so that's not going to return anything, right? Or I want you to just return everyone who has a B. So when I run this, I only see people who have a B because no one has an A. Now, if I change Francisco to have an A, then Francisco would also show up. Or let's do this one. All right, so now we see that Bob shows up because Bob meets the first conditional, where their grade is equal to an A and they are older than 18. And that's how our comparison operators work. Does anyone have any questions over SQL queries or anything that we've covered today? Okay, perfect. Let's break off into our group exercise in that case. I'm going to go ahead and stop the recording.